friends? Okay. All right. So number one was kind of a sleeper, difficult question, it sounds like. So let's see here. America, you and Julian come up with an idea for why. Why is it only the mom who passes on? You get your nuclear DNA is 50-50, and that's mostly what your body uses, right? But your mitochondrial DNA is just your mom. Any idea? Nothing? Nothing came up? Okay. Denise, anything come up with you and Brittany? Yes, it's all about the egg. I'm going to try to draw a little mitochondria. These are the mitochondria. I'm going to color them red. This middle part's the nucleus. Okay. So, what needs to join the egg? The sperm, right? So the sperm joins the egg, but does it give any mitochondria when it fertilizes the egg? No. So at fertilization, no mitochondria from the father enters the egg. That's a pretty killer diagram. So there's no mitochondria from the dad. There is mitochondria in the mother's egg, right? Those where all those little red things are. And then after fertilization happens, what's going to happen to the egg? It's going to go from one cell to how many cells? You guys read that okay? At fertilization, no mitochondria from the father enters the egg, from the sperm. That I should have said the sperm. Which is from the father. So that fertilized egg is made out of the mom's mitochondria. And then it gets fertilized. Nico, what happens? What does that one egg start to do right away? One egg turns into multiple, right? What's that process when a cell makes a copy of itself called? From last unit. Starts with an M. Miguel, you remember? Mitosis, yes. So, egg then goes through mitosis. And then by doing that, it copies mother's mitochondria. So you just get more and more cells. All of those new cells have the same mitochondria from that original egg cell, right? That's being copied and copied over and over and over again. Okay? So remember, what you see in yourself used to be this one egg, right? And that one original egg, it just had your mom's mitochondria in it. It just got copied over and over again until you come big like you are now. But all of your cells still have those original mitochondria. So maybe there's some other way I can explain that. It'll sink in a little better. We'll see. I'm going to maybe investigate that. Okay, now it sounds like number 2 was a little easier for everybody. Why, or were we able to develop solid evidence that it was the Tsar and Tsarina in that grave? Ashley, what did you guys talk about at your table? So we got a family sample, right? Now we know since all people who share the same mom have the same mitochondrial DNA, we used a living maternal relative for the Tsar. We found one for the Tsar and Tsarina. For the Tsarina, I think it was Prince Philip, who just actually died a couple years ago. He was Queen Elizabeth's husband. And who was, I think it was a Duke something that we used to get the father. But we got a living maternal relative. We got their mtDNA. And we know any Romanov should match that, right? We know that any Romanov should match. Should match that mtDNA. And Ashley, what did we find out? Oh, so let's not do that. But please don't go on YouTube right now. Please. Or something else. Man, kids these days. Dang. So what did we find out? Well, we know that they should match the living relative, the mtDNA from skeletons in the grave. Did it match the living relative? Did it match the DNA we thought they should match? Did we find skeletons that matched? We did, right? We did. They matched what we know should be any Romanov. Okay? mtDNA matched. It is the Tsar and Tsarina in that grave in Siberia. They match. It's not just some old skeleton or some old, a lot of people were murdered at this point in time in the Russian Revolution. There's a lot of dead bodies to go around, unfortunately. It could be a lot of different things. A lot of different people, but it wasn't. It was all matched up with those living relatives, so we know those were the Tsar and Tsarina. And not just the Tsar and Tsarina, but who else was in that grave? That we know for sure. You remember? Tsar and Tsarina. Any other members of the family we positively identify in the grave site? Well, did we find Alexander? Did we find any young male? We didn't, right? What's that? Well, the dad is an adult male, right? From bone study, we know there weren't any kids there. So we ruled out Anastasia and Alexei. But who else was part of that royal family? besides the king and queen and Anastasia and Alexei? Anybody else? America. They had 3 other daughters. Okay, they had Olga, Tatiana, and can't remember Maria, Olga, and Tatiana. So those 3 princesses were found to match the mom. So we had 4 DNA samples all matching. That covers the mom and the 3 daughters. And we had the Tsar match the maternal Tsar mtDNA line. Okay? All right. So what I want you to do right now, I'll come up and show you on the board, but